Let's keep going with integration by parts. I want to start us with a silly simple question. If you had the formula x equals 10 minus x, could you solve for x? I think you'd what? Add x to both sides. And over here you get 2x equals 10 plus 0, right? And so then you'd get x equals 1/2 times 10. You've been doing that kind of thing for a while, right? What if I made it more complicated and said stuff equals frowny face minus stuff? Could you solve for stuff? Well, it's the same thing as before, right? Just add stuff to both sides. And what do you get? 2 stuff equals frowny face. And then divide both sides by 2. So you get stuff equals 1/2 frowny face. Okay, and so here's a challenge. What if you had 3 times stuff equals 7 times frowny face minus 19 times stuff? Could you solve and get stuff equals some version of frowny face? I think you could. So let's just keep that in mind. And I'll give you an integration by parts problem. How about the integral of sine t times e to the t dt? What are you going to use? Oh, did I give away that this is integration by parts? You should use integration by parts. What are you going to do for u and dv? Well, let's think through Liate. Do I have any logs? No. Inverse trig? No. Algebraic stuff like just plain t? No. Trig. I do have some trig. So I'm going to use trig here. So I'm going to say u equals sine t. And then what is dv? That would be e to the t dt. So go ahead and do the next part. So we have du equals cosine t dt, and v equals e to the t. And then let's write the integration by parts formula. U times v minus the integral v times du. So go ahead and fill that in. So we'll have sine t times e to the t minus the integral of v is e to the t, du is cosine t dt. Okay, well that part's fairly simple. You might have kind of guessed that we'd get that. And what do we do with this? That looks a lot like we'll need integration by parts, right? It's the integral of a product of things. So this is going to need integration by parts. And it's not one that we just did in a previous video, so we can't go copy the answer. So what are we going to do for the integration by parts there? Let's think through Liate. Any logs? No. Inverse trig? No. Algebraic, like polynomials? No. T, we do have a trig function. So we'll say u equals the trig function, cosine, and dv equals whatever's left, e to the t dt. And then what's the integral of cosine? What's the derivative of cosine? Negative sine. And v equals e to the t. And then we'll write the integration by parts formula. So let's kind of keep our whole thing together here. Sine t e to the t minus, and then this whole integral is within those parentheses. Let's write u times v minus integral v times du. So what is u? Cosine t. V is e to the t minus the integral v is e to the t, and du is minus sine t dt. That's looking like we're going to need integration by parts. Have we done that problem before? Oh, yes, we did. Way up here, that was the problem we started the whole example with. So can we just go copy the answer? Well, we don't have an answer yet. We're in the middle of doing it, right? So what are we going to do? I hardly ever simplify things, but in this case, I'll make an exception. I'm going to put this minus and that minus, I'm going to turn into overall a plus sign. I still have a minus out there, though. You can see how it's easy to get mixed up with your minuses and pluses here, right? So what are we going to do? Let's think back. This whole expression was equal to that, right? So we have integral sine t e to the t dt. And that integral, that's what we started with, is equal to all this stuff. What can we do? Well, we have the same thing here and there. Let's write it again and distribute this minus. It'll make it a little bit more obvious what's going on. Integral sine t e to the t dt equals sine t e to the t minus cosine t e to the t, and this minus comes in, it's that minus e to the t times sine t dt. Let's look back at what we've done so far in this video, maybe all the way back here. Do we have basically stuff equals other stuff minus the original stuff, right? Like we had up here. So we're going to use the highly technical terms here. Stuff equals, we'll call all that frowny face, minus the original stuff. In textbooks they use letters like I standing for integral, but we know it's really stuff. So now can we solve and say stuff, which is our original integral, equals something? So we'll add stuff to both sides. We'll get 2 times stuff equals frowny face. So stuff equals 1/2 times frowny face. And we're done. Maybe we should put back the original symbols. So integral of sine t e to the t dt, that was our stuff, is 1/2 times this frowny face expression, sine t e to the t minus cosine t e to the t. And maybe now we can throw in a plus c. Now you could simplify this by bringing the e to the, factoring out the e to the t. Doesn't matter to me. But let's notice what happened here on the previous example, previous video. We did integration by parts on something, and we got a simpler version that still needed integration by parts. And we kind of did that. We just kind of looked up what we had already done. You might wonder what's going to happen if I had a t cubed e to the t here. You could probably guess what pattern you're going to see. It's just repeated integration by parts, right? Here, we did integration by parts. We needed integration by parts again, so it's repeated integration by parts. But we ended up getting into kind of an infinite loop, and we had to break out of it by noticing that we were doing the same thing again. So that's 2 big patterns in integration by parts. Repeated integration by parts, and repeated integration by parts, getting caught in a loop and then breaking out of it by noticing what's going on. So those are things to keep in mind.